Hello everyone, today we'll be continuing, this is another session on the theory of polynomial equation. So we were discussing about quadratic equation in particular. So today we'll be talking about another topic which is very important from the quadratic equation format, and that is basically the topic of common roots. So the sums that come from common roots are fairly straightforward, but nevertheless you need to know the concept associated with common roots. So let's start off with it. So suppose the equations a1x squared then b1x plus c1 is equal to 0, and we'll have another quadratic equation of the format of a2x squared plus b2x plus c2 equal to 0. So these are the two quadratic equations, and these two quadratic equations have a root in common. Okay, so these two quadratic equations have a root in common, and we'll assume that let alpha be the common root. So that will be our assumption. So we have already mentioned that these two quadratic equations have a common root, and we have taken that common root as alpha. Okay, so what does that imply? So basically implies that if we put alpha in place of x in both these quadratic equations, we'll get the value as 0. So that will give us that we'll have these equations basically a1 alpha squared plus b1 alpha plus c1 is equal to 0. So this is basically we can take as equation 1, and also we'll have a2 alpha squared plus b2 alpha plus c2, this will be also 0, and this will be equation 2. So now we can write it down as alpha squared. So alpha squared will be equal to, and in the, so this will be alpha squared, that will be equal to alpha, and here this will be 1 by something. So this will give us that if we take alpha squared, so alpha squared will be basically equal to b1, let me use another ink so that it is more clear to you. So this will give us, we have to basically multiply b1 c2 and then b2 c1. So this will give us alpha squared will be alpha squared by b1 c2 minus b2 c1. This is one condition, and the second will be c1 will be multiplied. Basically if we write c1 over here and c2 over here, then c1a2 minus c2a1. So this will be equal to c1a2 minus c2a1. This is another condition, and the third will be multiplying a1 b2 minus a2 b1. So this will be a1 b2 minus b2, or rather this is not, let me rub it out. Okay, so this will be b1 a2. So this is the structure that we are looking forward to. So what does that imply? So that implies that alpha square will be equal to b1 c2 minus b2 c1 by a1 b2 minus b1 a2. So what we have done over here, we have taken this part and this part, and we have cross multiplied. So this gives us the value of alpha squared. And similarly, if we take these two parts, then this will give us that alpha will be equal to c1a2 minus c2a1 by a1 b2 minus a2 b1. So this is the structure that we're looking forward to. So what we'll now do, so basically that means that the square of this term is equal to this term. The square of this term is equal to this term. So we have already found out this. So now we'll proceed with this similar condition. So first let me rub it out and make space for the same. Okay, so now we are good to go. So that will give us that b1 c2 minus b2 c1 by a1 b2 minus a2 b1 will be equal to the square of this term. So this will be equal to c1 a2 minus c2a1 by a1 b2 minus a2 b1 whole square. So as you can see over here, this term and this term will cancel out, and will be left with only one a1 b2 minus a2 b1, and that we can take over here. So this will give us b1 c2 minus b2 c1 into a1 b2 minus a2 b1, and that will be equal to this term. This will be equal to c1 a2 minus c2 a1 whole square. So this is the condition that we finally land up with. This is the condition if we have one root common in a1 x square plus b1x plus c1 equal to 0, and a2x plus b2x plus c2 is equal to 0. So that are the two conditions that we are looking forward to. So this condition ultimately comes down, so when we are solving the problem. So now it is not a case that you need to remember this formula, but the structure that will follow while solving such kind of questions from having one root common, this is the structure and the way that you should be following. And basically, you are in that kind of questions, you are basically asked to find out the relationships between the various roots or the various coefficients, alpha, beta, or whatever is given in the question. So this is a structure that you should follow. So I hope you are very much clear with the structure that you need to follow. Now the next part that we need to talk about is that what happens if we have both the roots common. What happens if we have both the roots common? So let me write it down. So that will be both roots are common. So both roots are common, and we'll take the same examples as the earlier one, where we took that a1x square plus b1x plus c1 is equal to 0, and we took a2x square plus b2x plus c2 is equal to 0. So here also basically we'll assume that these two quadratic equations have both roots common. So if that happens, so this will give us that the condition that will get done is a1 a2 will be equal to b1 by b2, and that will be equal to c1 by c2. So as you can see, this is the final condition that we'll end up with. Now there are some subcategories or some trick questions which are basically trick concepts which are associated. So suppose these two quadratic equations have one complex root common. So if these two equations have one complex root common, and let that root be p plus iq. So if p plus iq is a common root to this two quadratic equations, then p minus iq is also a root of this two quadratic equations, since I already mentioned that if p plus iq is a root of a quadratic equation, then p minus iq, that is conjugate, will also be the root. So basically that root will occur in both these cases, in both in the quadratic equation 1 and the quadratic equation 2. So that implies that these two equations have both the roots common. So that will imply that this condition is valid in this case. Similarly, if you have a root of the format p plus root q, then you will also have another root p minus root q. So if it is given that p plus root q is a common root of these two equations, then you can directly apply the condition for both roots common over here, since p minus root q will also be the root of these two quadratic equations. So these are the small tiny little bit tricks and concepts which are associated with both roots common, and I have already mentioned about the condition that you need to follow if both the roots, if the only one root is common. So these are the things that you need to keep in mind. So if you have any doubt regarding this topic of common roots, then you can comment in the comment section below, and we'll try to get back to you. Thank you very much.